It's a beautiful summer day here in Palawan, and it's the perfect time to get a tan line. Whoa! Look at that clear effect of ultraviolet photons! Light exhibits wave-particle duality, that is, light acts sometimes like waves, as demonstrated by reflection, refraction, interference, and diffraction, and sometimes like particles, as demonstrated by its behavior in terms of emission, absorption, and scattering. In a time where the wave nature of light was firmly established, the photoelectric effect was a phenomenon that baffled scientists. It was Einstein's radical photon concept that solved their dilemma. In Einstein's picture, the energy of light is quantized. A beam of light consists of particle-like packages of definite energy called photons. The energy E of an individual photon, or quantum of electromagnetic energy, is equal to the Planck's constant h times the photon frequency f. An individual photon of energy hf is absorbed by a single electron. Unlike the continuous transfer of energy in the wave theory of light, the energy transfer in the photon picture is an all-or-nothing process. This reinterpretation of light explains the photoelectric effect beautifully. Let's take a photoelectric material. An electron can only escape from its surface if it absorbs enough energy from the photon. The higher the frequency, the higher the energy. In the wave model, it's a higher amplitude that should give a higher energy. The photoelectric effect disagrees and supports the photon picture. So does that mean we want solar panels that convert UV light? Not necessarily. There are more visible light photons than UV photons. Assuming they both pass the threshold frequency, visible light gives us more electrons than UV light does. It's kind of like quantity versus quality. Further proof of the particle nature of light is given by the inverse of the photoelectric effect, X-ray production. Instead of releasing electrons from a surface by illuminating it, radiation, specifically X-rays, are emitted from a surface by bombarding it with fast-moving electrons. Fun fact! Your bones appear white on the X-ray film because they absorb most of the photons, unlike the rest of your body. Moving on, considering light shown through two slits and onto a photomultiplier, though the wave description of light explains the interference pattern, the particle description of light explains the records of discrete packages of energy. Going back to her tan line, this happens because ultraviolet photons in sunlight have enough energy to trigger a chemical reaction in her skin cells that leads to the increased production of the pigment melanin. Ultraviolet photons actually have enough energy to break the bonds within DNA molecules of microorganisms. It could be dangerous for us too.